Have you ever looked at the standard model of relativity and just felt a little bit of cognitive dissonance?
Oh, absolutely. I think anyone who really digs into the math hits that wall eventually.
Right, because we are taught that as an object approaches the speed of light, it literally physically crinks.
Along its vector of motion, yeah.
Exactly, it deforms. And we just accept this as a fundamental rule of how space-time works. But what if that famous space-shrinking phenomenon feels like mathematical magic because, well, maybe it is.
That is the million-dollar question we're looking at today.
Yeah. What if it's actually just an optical illusion, one created by how we geometrically sample light?
Welcome to this deep dive. Today, our mission is to explore something called the Zyonod-Chet theory.
It's quite the document.
It really is. We're looking at a radical, highly geometric, 62-page reinterpretation of the classic Michelson-Morley experiment and Lorentz contraction. The whole goal here is to break down this paradigm shift into visualizable aha moments.
Replacing the black boxes. Exactly. Replacing what the author calls occult mathematical black boxes with logical geometric procedures that actually respect cause and effect. So, okay, let's unpack this. We're going to take you on a journey from a flat, two-dimensional illusion into a massive 3D sphere of light.
And we really need to set the tone here, because we aren't just looking at what this new theory claims. We are going to learn why the traditional physics approach might have been looking at the universe through a fundamentally flawed lens from the very beginning.
A flawed lens. I love that phrasing. And that conflation is most obvious in what the text calls the trap of the 2D God's eye view.
The God's eye view, right? It's a classic mistake in theoretical physics.
Because when you look at how physicists traditionally analyze the Michelson-Morley interferometer setup, they treat the whole thing as if it's happening entirely on a flat surface, the Xi-plane.
Right. They design a mathematical space like a standard Cartesian coordinate system, and then they confuse that mathematical map with the actual physical world.
They treat the light beams and the mirrors like they exist in this purely horizontal geometry.
Which is where the God's eye concept comes in. It's this mistaken assumption that everything on that 2D plane just exists simultaneously.
Like you're hovering above it, seeing it all at once.
Exactly. It assumes there's no physical procedure, no travel time for the information to actually get from point A to point B.
You're just treating time as a static background grid.
Yeah, rather than a dynamic physical process that is strictly governed by the finite speed of light.
And this brings up the most crucial missing element in the traditional physics model, which is the z-axis, the depth.
They completely ignored it.
Completely. By ignoring that vertical space, the traditional equations essentially erased the physical history of the light arriving at the experiment.
Yeah.
The travel time is just gone.
And this raises an important question. How can we possibly measure light accurately if we just completely ignore the journey it took to reach the measuring device in the first place?
Right, you can't just arbitrarily start your stopwatch. The exact microsecond light enters the device and pretend nothing happened before that.
You really can't. You have to account for the mechanical procedure of the light radiating from the broader universe and finally arriving down at the detection point.
So to fix this, here's where it gets really interesting. The Zyonod-Chet theory introduces this drastic shift in scale. I want you to picture a giant sphere.
A really big one.
Massive. It has a radius of exactly 300,000 kilometers. Now, why that specific size?
Because that is exactly the distance light travels in a vacuum in 1 single second.
Exactly. 1 light second. The source material refers to this giant shell as the public space.
It's conceptualized as a volumeless shell of point clouds. It acts as the absolute origin source, or the fire, of the light.
The fire, I like that. So this giant boundary is where the light originates. Now, we take our tiny standard interferometer device.
Which is about 3 meters wide.
Right, a 3-meter wide device. And we place it right smack in the dead center of this colossal 300,000 kilometer sphere. The disparity in scale is just wild.
It is extreme, but it's necessary. Because that scale disparity forces us to make a vital distinction that traditional physics completely missed.
Between the two types of light.
Right. The theory draws a hard line here. First, you have what they call experiment light.
Which is just the light bouncing around horizontally inside the 3-meter device.
Exactly. But the crucial addition is what the text calls timestamp light, or engraved light.
The light raining down from the giant sphere.
Yes. The light traveling from the massive 300,000 kilometer public space boundary, dropping down through that z-axis depth we talked about, to finally hit the tiny device at the center.
And because it takes exactly 1 second for that timestamp light to drop from the giant sphere to the tiny device, there are always 2 timestamps. Always.
You have to account for both.
Right. Stamp A is when the fire started on the outer shell. That's 0 seconds.
The genesis.
Yep. And stamp B is when it finally hits the device in the center, which is exactly 1 second later.
And traditional physics completely ignored this 1-second physical procedure. They treated the moment of intersection as if it was the absolute beginning of the universe for that experiment.
They assumed a simultaneous now across the whole device.
But geometrically, that's impossible. If you have a 3-meter disk at the center of a 300,000-kilometer sphere, the light raining down from the boundary doesn't hit every single point on that disk at the exact same microsecond.
Because the center of the disk is technically closer to the boundary than the outer edges.
Exactly. The varying distances create a tiny gradient, a topographical map of slightly different arrival times.
So even when the device is completely stationary, it's not experiencing a uniform now. It's actually sampling a tiny spectrum of the past.
Yes, and that is just when it's sitting still.
Oh, man. Okay, so let's put the system in motion. Let's imagine what happens when this entire setup, the giant sphere and the tiny 3-meter device starts moving.
Through the electromagnetic field.
Right. Let's accelerate it to 60% the speed of light. So 0.6 c. What happens to those timestamps?
They get completely skewed because of a Doppler-like effect. The light in the field is moving at c, but the device is now rushing forward at 0.6 c.
So it's rushing toward the light coming from the front of the giant sphere.
Right, so the relative closing speed for the light hitting the front of the device is 1.6 c.
Which means it gets there faster. Let's do the math. If you divide the 1-second distance by 1.6, the light from the front hits the device in just 0.625 seconds.
Exactly. But you have to look at the light chasing it from behind, too. The device is running away from the light emitted at the rear boundary.
So the closing speed drops?
It drops down to 0.4 c.
Wow. So dividing our 1-second baseline by 0.4, that light takes a grueling 2.5 seconds just to catch up to the back of the device.
So now look at your timestamps. Light hitting the front says 0.625 seconds. Light hitting the back says 2.5 seconds. The reality being stamped onto that 3-meter device is completely asymmetrical.
The timestamps are completely skewed. They are no longer perfect, symmetrical, concentric circles.
Not at all. Geometrically, they distort into a skewed, purplish-red ellipse.
A purplish-red ellipse. So what does this all mean? This is the huge revelation here. If the timestamps warp into an ellipse, it means Lorentz contraction, the famous physical rule that moving objects shrink is not a physical deformation at all.
The chassis of the device maintains its exact structural integrity. It isn't shrinking.
Mind-blowing.
It really is.
Yeah.
The purplish-red ellipse is simply an informational scanning geometric cross-section.
That's a mouthful. Break that down for us.
Sure. Think of Minkowski spacetime. The incoming light forms a 3D light cone. When you're stationary, your plane of simultaneity is flat, horizontal. You slice the cone straight across, you get a circle.
Right.
But when you accelerate, your sampling times change. You've got that 0.625 second stamp on one end and a 2.5 second stamp on the other. That tilts your plane of simultaneity.
Ah.
You are now slicing through that 3D light cone diagonally, and geometrically, if you slice a cone diagonally, you get an ellipse.
So the shrinking we think we see is just a mapping artifact.
Exactly. It's a geometric illusion caused by our moving window sampling different moments of the past.
We are just taking a skewed sample and projecting it badly.
Which is exactly what the source material explains with the double stamp logic.
Oh, yeah. Walk us through the double stamp mechanism.
So stamp 1 is the raw objective reality. It's the information from the public space hitting the sphere surface in 3D.
Where light travel actually requires time and distance.
Right. Then you have stamp 2. The author defines stamp 2 as a stereographic projection.
Like cartographers use for Earth.
Precisely. It's like projecting a 3D globe from the North Pole down to the South Pole onto a flat 2D map. We know that forces severe spatial distortions. Greenland looks massive.
Right, because you are forcing a 3D reality onto a 2D mathematical map.
And the Zionad-Chat theory argues that time dilation and length contraction are just the mathematical distortions inherently produced by the stereographic projection. The 2D map assumes the object shrank because a 2D map simply cannot process a diagonal temporal slice.
It just doesn't have the geometry for it. And, we should mention this theory builds upon some earlier work, specifically Dr. Akifumi Higashi.
Yes, Dr. Higashi's concept of a dense clock field.
Right, the idea that space is saturated with independent temporal coordinates, independent clocks.
It was a vital precursor. But the Zionad-Chat theory uniquely refines it by introducing the public space as a strict geometric window. It anchors those independent clocks to an absolute boundary, which makes the whole thing mechanically provable.
It takes the math and gives it actual physical mechanics.
Which is why this is such a philosophical triumph. If we connect this to the bigger picture, this is what the author calls anti-occult physics.
I love that term, anti-occult.
Because for over a century, the math of relativity has worked. But the physical mechanism behind it was completely opaque. It felt magical. But by defining simultaneous points based on their temporal and directional distance from the origin.
Accounting for the actual travel time.
Yes, this theory restores physical procedure and cause and effect to physics. It removes the black box of relativity. It proves that you don't need magical space shrinking to explain the universe. You just need to understand the geometry of how information is actually sampled.
It's just brilliant. Let me try to summarize this journey we just took, because it is quite the mental leap.
Decker.
We started by looking at the flawed, flat 2D assumption of classical physics, the God's eye view. Then we expanded into a massive 300,000-kilometer 3D sphere to actually track the physical history of light.
The timestamp light.
Right. And by doing that, we discovered that when a device moves near light speed, it doesn't physically deform or shrink. Instead, because it's rushing toward incoming light and running away from chasing light, our sampling of time and space simply warps into a diagonal slice.
The purplish red ellipse.
The purplish red ellipse. The shrinking is just a stereographic double stamp projection. It's an illusion.
You really love these geometric cross-sections, don't you?
I can't help it. It just makes so much sense when you visualize it.
It does. And it's a profound reminder that true knowledge really comes from questioning our most basic mathematical maps.
Yeah.
We can't confuse the map with the territory.
Mistaking the map for the territory. That is exactly it. Which brings me to a final lingering question for you to ponder on your own after we wrap up here.
Oh, here we go.
If our entire unquestioned understanding of space contracting and time slowing down is actually just a double stamp projection, a simple geometric illusion caused by our limited moving point of view, what other unbreakable laws of our daily reality are just optical illusions waiting for a wider perspective to decode them?